Right, let's have a look at number 4 here. So we have been given an equation for some curve. 3 over x plus 5 equals minus 2x plus c, where c is a constant, has no real roots. The equation has no real roots. The key thing I'd underline here in this question is no real roots. That should trigger in your mind something that you have learned when you were learning quadratics. When I see the word no real, or the phrase no real roots, I am thinking about the discriminant, and specifically the discriminant being less than 0. It's not a quadratic at the moment, but this is sort of my starting point. B squared minus 4ac is less than 0. So let's see if we can try and make sense of this. So 3 over x plus 5 equals minus 2x plus c. And I've got x in the denominator here. And to get rid of it, I would have to multiply everything by x, which is what I'm going to do. And I actually write times by x sort of in subscript next to each term, so that I remember to multiply every term by x and I don't forget, because that's often a place where I've seen students make a mistake. So this crosses out with this to leave us with a 3. 5 times by x is 5x equals minus 2x times by x is minus 2x squared, and I'm going to get plus cx. Now this is looking more like a quadratic. To make this easier to deal with, I am going to bring everything over to one side, and I like to do it where x squared is positive. So 2x squared plus 5x minus cx plus 3 equals 0. And what I'm going to do now, you notice here that there are 2x terms. We can combine that together by writing x and sort of factorizing x by those two terms. So it's 5 minus c plus 3 equals 0. So hopefully you are happy with everything up to that point. Now, don't forget, we started off with our trigger being b squared minus 4ac should be less than 0. Now that we've got it in this quadratic form, we can identify a as being 2, b as being 5 minus c, and c being equal to 3. Let's not get this c here confused with the coefficient of the general quadratic. Okay, they're entirely separate. In fact, that should have been called k in the exam to avoid confusion. So let's have a look at this. We're going to start off by saying b squared minus 4ac is less than 0. So b squared, 5 minus c, 5 minus c. Notice I don't write squared. I just multiply two of the same brackets by themselves. And this again is to avoid mistakes on expansion of brackets, especially during stressful times such as exams. The less thinking that you do in terms of actually thinking problems through, and more you write down on your piece of paper, the easier the exam is going to be, I feel. Don't work out too many things in your head. All right, so now if I expand that, we're going to get 5 times 5 is 25. Minus 5c is going to give me minus 10c. Minus c times minus c is plus c squared. Again, notice if you made a mistake on expansion, then you know really should not have dropped marks on that. Okay, so just be careful with that. minus 4 times by 2 is minus 8 times by 3 is 24. So now we are getting to a quadratic inequality here. C squared minus 10c and then I've got plus 1 is less than 0. Okay. Now this is a quadratic inequality. For quadratic inequalities, what's good is to be able to sketch them or find the roots so that we can sketch them and shade a region on the graph essentially. So maybe what I'm going to do is complete the square. You can find the solutions many ways. I'm going to say c minus 5 squared minus 25 plus 1 equals 0. C minus 5 squared equals 24. C minus 5 equals plus or minus root 24. C equals 5 plus or minus root 24. Now root 24 is less than 5 because root 25 is 5. So essentially what we get is some sort of a quadratic that looks like this. This is going to be 5 minus root 24. And this point here is going to be 5 plus root 24. This point here was 1, x, and this is y. Now we want to know where this quadratic here, this is the quadratic, is less than 0. Well, it's less than 0 when it's below the x-axis, the region that I have shaded in red there. And so the values of c are going to be c lies between 5 minus root 24 or 5 plus root 24. As long as c lies between these two values, there are not going to be any real roots for this equation, is what we have found out here.